My name is David Adam and I have obsessive compulsive disorder, OCD. I want to find out more about my condition, so I've come to the University of Cambridge to find out how some of the top scientists in the field are studying this disorder. I've seen how they use animals to understand what's going on in the brain. But OCD is a human condition, so how does this research relate to the human brain? I've come today to meet Dr. Annemieke Apergis-Hout, who uses cognitive tasks very similar to those we've just seen carried out on animals, but using human volunteers. And today, that's me. Ultimately, of course, scientists need to compare what they've learned from animals with what is happening in the human brain. Cognitive tests can tell us a great deal about the OCD brain, but to see which areas of my brain are involved in my OCD, Annemieke is going to conduct a similar test while imaging my brain in a brain scanner 60,000 times the strength of the Earth's magnetic field.
So David, you're about to go into the scanner.
Okay.
Where you just be laying down and watching a screen, and you'll see two angry male faces. And your job is to figure out after which face you might be getting a shock.
Okay.
At the same time, we will be recording your skin conductance, where we can see tiny changes in your sweat to see when you might be expecting a shock. And you also have a shock electrode on your other wrist through which you'll be getting those little shocks. Okay, so David, you were just in the scanner. What did you notice about when you were getting shocks?
So at the beginning, I definitely felt that I was getting shocks from the green faces. And then I got a bit confused because the red faces seemed to join in.
Well, that's very interesting, because that's what we overall find in OCD patients, that initially they realize they're getting shocks to the green face and that the other one is safe, as we see by their skin conductance responses. But in the middle, when unexpectedly now the red face is giving shocks and now the green one has become safe, there's no difference between their skin conductance responses in this part. And what we see from the OCD patients in their brain is that they have a region here in the medial front part of the brain that is hyperactive throughout differentiating these two faces. So in the healthy controls, we see that this region actually signals when a stimulus is safe, but it doesn't seem to do this for the OCD patients.
Okay, so that's something that you can look at in the human brain, and there's people like me who are very happy to volunteer for you to have a look in our brains. So once again, it asks the question, why bring the animals into it?
So with humans, we can see correlations between brain regions and what happens when they do a certain task, but we can't see things on the neuronal level, and we also can't manipulate the brain. So we can't stimulate a certain region or maybe even ablate a certain region, take it out. We can't put drugs in to see what happens if the levels of certain neurotransmitters change. So in an animal we can model, we can do a lot more that we're not able to do in humans on that much more specific level.
So that bit that you've pointed to, the bit that you think is implicated in OCD, it looks quite difficult to get to.
Yes, well it is. It's all the way in the middle, on the bottom of your frontal cortex. And actually with deep brain stimulation they have to go very deep into the brain to stimulate, and they are able to do that when they go in from an angle.
Deep brain stimulation, what's that?
Deep brain stimulation is when you get electrodes placed in regions of the basal ganglia which are deep into your brain, and you sort of have a pacemaker for the brain that's always on and stimulating at a certain frequency. So we're actually right now doing the first deep brain stimulation trial in collaboration with University College London, where we have the first 6 patients signed up, and we're really hopeful that this will be an opportunity to give them their life back from OCD.
So I've seen some of the research now at the university, and I came in interested and a little sceptical about the animal research, but I think what is most striking for me now, those images of my own brain, seeing those on the computer screen, it's quite humbling, and it's also quite emotional for me, because of course that's where it all began. And I think we like to think of the brain as being sort of uniquely human, and of course it is, but also seeing it in that way, cut away, made me realise that I'm an animal, and my brain is a part of my body in the way that the other organs are, and when the other organs go wrong, we try and treat them, and so it is with the brain. But we're probably not as advanced with some of those treatments, and certainly not with OCD. It's worth remembering that the treatments for OCD they're better than they used to be, and they help people, certainly. They certainly help me, but they don't help everybody, and they're not particularly good for some people, and so we need to keep trying to find better treatments. And I think, if I'm honest, I think some of the research that I've seen probably won't lead to any breakthroughs, certainly in time to help me, but hopefully in time to help the next generation. And you know, if we want to try and develop better treatments and new treatments, then I think we do need to treat the brain like any other part of the body, and we do need to experiment with it, and we do need to find out what goes wrong, and I guess we can't do that work with humans. So I think we have to do some of that with animals, just to maybe not to develop new treatments immediately, as some people might talk about, but mainly just to give us the knowledge to try and improve and develop new treatments in the future, because I think sadly, as far as my generation goes and me, it's probably too late. You know, we have to make do with the rather crude tools and treatments that we have now. But hopefully, for the next generation, it's not too late.